afternoon, students. In the last class we have discussed about rate constant or velocity constant, then rate law and order of the reaction. So for any reaction, rate law is given by rate is equal to k into a raised to x into b raised to y, and this same is given by the differential rate equation dr by dt is equal to k into a raised to x into b raised to y. And in this rate law, rate constant is calculated as rate is equal to r when concentration of all the reactants are unity. Okay. And next I have just discussed about the order of the reaction. Order of the reaction is nothing but it is the sum of powers of the reactant terms raised to the powers in a experimentally determined rate law expression. Okay. Now next we will study the features of order of the reaction. Features of order of the reaction. Features of order of the reaction. Okay. So here features in the features of order of the reaction. This is important. It may be asked in 2 marks. So make a point of it. Order is perfectly experimental value. Order is perfectly experimental value. So it may or may not be equal to stoichiometric coefficients. It may or may not be equal to stoichiometric coefficients. In some cases it may be equal to stoichiometric coefficients, and in some other cases it may not be equal to stoichiometric coefficients. So that I have cleared you by giving the examples. Okay, 5 examples I have solved in the last class. Now, so next it is the values can be 0, 1, 2, 3 or even a fraction. That means order of the reaction can be a fractional value. It can be 0 or it may be the values 1, 2, 3. Okay, anyone. Then it is perfectly experimental one. It measures or give measure of rate of the reaction. It is a measure of rate of the reaction. Okay. Then next point. For a complex reaction, this I will cover in the next part. For a complex reaction, overall order is given by slow step of the reaction. Okay, this part I will cover in the next part. So for complex reaction, overall order is given by slow step of the reaction. Now based on the order we can classify the reactions into 5 classes. Based on order, type of reactions. Based on order, type of reactions. So here first zero order reaction. So this may be asked in 2 marks. Okay, question will be like this: define zero order reaction, give an example, or define first order reaction, second order reaction, anyone, or it may be asked for 2 marks. Zero order reaction. So here order will be 0. That is, here rate of the reaction is independent of concentration of reactants. This is one definition. Or order of the reaction is 0. This is second definition. Or third definition, rate of reaction is dependent on zeroth power of concentration of reactants. Okay, in 3 ways we can define the zero order reaction. So that first definition is rate of the reaction is independent of concentration of reactants. Second definition, order of the reaction, first order reaction. So here first order reaction is given by rate is dependent on first power of concentration of reactants. So general format is given by R is equal to K into A raised to 0. Okay. So this is the format for zero order reaction. Here in this, the format for rate law will be R into A raised to 1. So now examples. Another definition it can be given as the reaction which has order 1. But that definition does not suit here. We have to give in terms of concentration of reactants only. Okay. So first example, 2N2O5 giving rise to 4NO2 plus O2. So rate law for this equation is given by R is equal to K into N2O5 raised to 1 and is equal to 1. Okay. Second example, H2O2 giving rise to H2O plus half O2. R is equal to K into NOH2O2 raised to 1 and is equal to 1. So here nothing explanation is there, just the definition and examples. Okay. You need not explain the examples. Third category, second order reaction. So same definition. Rate of the reaction is dependent on second power of concentration of reactants. Rate of the reaction is dependent on second power of concentration of reactants. So same examples I will cover here. First example, that 2NH3 giving rise to N2 plus 3H2. Okay, just the reaction. N is equal to R is equal to K into NH3 raised to 2. Don't make confusion here. So in order to have a zero order reaction, we must have some special conditions that must be shown on the arrow. Otherwise, the reaction will be of higher. Okay. Second one, esterification, saponification of ester. Okay. In this reaction, CH3, COO, C2H5 plus NaOH giving rise to CH3, COO, Na plus C2H5OH. This compound is ethyl acetate or methyl ethanoate is the IUPAC name of this compound. Ethyl acetate or methyl ethanoate is the IUPAC name of this compound. Generally we can see it as a ester. So that rate law is given by K into ester raised to 1 into NaOH raised to 1. So that N is equal to 2. Okay. So next example, or next type of the reaction. All these questions are asked under 2 marks. Take a note. Okay. If I had not written important, just you write down and practice it. Important asked for 2 marks. Important asked for 2 marks. Okay. Now next. Fourth type, third order reactions. So here, as per the definition, these reactions, third order reactions are generally rare. So here, rate of the reaction is dependent on third power of Fourth, now fifth type. Fifth type is nothing but fractional order reaction. Fractional order reaction. So here definition somewhat changes from the other definitions. Here we are writing as overall order of the reaction. Overall order of the reaction is a fraction. Overall order of the reaction is a fractional value or fraction. So that type of the reaction is called as fractional order reaction. It is also asked for 2 marks. Make a note of it. Then example first one. In the example first one, H2 gaseous plus Br2 gaseous in presence of H nu giving us to 2HBr gaseous. I will give you the rate law. Just you write the order. R is equal to K into H2 raised to 1 into Br2 raised to half. N is equal to 1 plus half is equal to 1.5. 3 by 2 or fractional order will be 1.5. So see here, in the fractional order reactions there may be 2 or more than 2 reactants, and in one reactant with respect to the power we are having the fractional power, so that overall order will be turning as a fractional value. Okay, it is not necessary that all the reactants should have a fractional order value. CO gaseous, carbon monoxide, it is not cobalt, Cl2 gaseous giving rise to COCl2 carbonyl chloride. Okay, so here rate law is given by R is equal to K into CO raised to 2 into Cl2 raised to half, N is equal to 5 by 2 or it is 2.5. Okay, next third example. CH3CHO gaseous heated at 773 Kelvin, then CH4 gaseous plus CO gaseous. So here rate law for the equation is given by R is equal to K into CH3CHO raised to 3 by 2, N is equal to 3 by 2. So here only one reactant is that, and with respect to that reactant we have a fractional power, so that overall order of the reaction is again a fraction. Okay, so see here I will just wind off my topics, but I will solve you some of the problems which you have studied in the last and this class. Okay, so let me solve 2 to 3 problems related to this order and rate law and rate constant. Okay, so take the question problems. Take the question. First one, calculate the overall order of the reaction. Calculate overall order of the reaction which has rate expression, First question, in that first question, R is equal to, rate is equal to K into A raised to half into B raised to 3 by 2. Second question, rate is equal to K into A raised to 3 by 2 into B raised to minus half. Okay, then third question, R is equal to K into A raised to half into B raised to 2. So this is the question, and this question is asked for 1 mark. So just you have to write the order. N is equal to 1 by 2 plus 3 by 2. It is 4 by 2, or order of the reaction is 2. In the first case, order of the reaction is 2. Second, 3 by 2 minus 1 by 2. It is 3 minus 1, 2 by 2. It is order of the reaction as 1. Then third, this is answer. So here I will just stop this topic and I will continue in the next